All right, so this is again a question about how do we graph this exponential function that we've got here at the top of the screen. And so first thing is we know that h of x is a variation of the more basic function 1/2 to the x. That's one function we can kind of treat as one of our parent functions. And 1/2 to the x is an exponential function whose base is between 0 and 1. And in that case, you get the shape of the graph of the exponential function looking like this. Runs through the point 0, 1, and again approaches the x-axis as a horizontal asymptote. And based on our knowledge of transformations, we know that the x plus 2 shifts this graph to the left by 2, and the minus 8 shifts the graph down by 8. So we're going to go to the left by 2 and down 8. So if I take this point left 2 and down 8, let's see, that's going to put me at -2, -7, so way down here somewhere. And of course, y equals 0 is the original horizontal asymptote, but if we shift everything down by 8, we'll have a horizontal asymptote down here at -8. And so our graph maintains the same shape, so it's going to look something like that. And again, to make the graph more accurate, we want to go find, well, where exactly is this x-intercept and where exactly is this y-intercept, because this is just a rough sketch, a general idea of what the graph looks like. And so if we get the two intercepts, then we have a much better idea, and we get a little practice at some algebra. So let's find the y-intercept. Plug 0 in for x. See if we can do this without a calculator. I think we can probably handle it. If we put 0 in for x, everybody's always quick to grab that calculator, but a lot of times you just don't need it. It's good for your brain to practice the arithmetic without a calculator. Right, so this is 1/2 squared minus 8. When we square 1/2, we get 1/4. I need the common denominator, so it would be 1/4 minus 32/4. So we can do that, we're okay. 1 minus 32 is negative 31/4. Right, and so we know from our rough sketch that it looked like, I mean, even though this is a rough sketch, I think it's okay. Right, we know this graph can't ever cross below y equals -8, so the y-intercept has to be somewhere here just a little bit above -8, and 31/4 is a little bit less than 8, so we're in the negative side here, so we would expect this to be around -7.8 or -7.9 or something like that. So that looks to be reasonable. If you divide 31 by 4, you get 7.75, right? So -7.75. Right, but that seems reasonable, something that's just a little bit smaller than 8 for our y-intercept. Okay, and so for the x-intercept, set the entire function equal to 0. And so I'm going to add 8 to the other side. And then I'm going to attempt to get base 2 on both sides. So 1/2 I can write as 2 to the minus 1. 8 I can write as 2 cubed. And now on this left side I can multiply the exponents. And since I have the same base 2 on both sides, that means that my exponents must be equivalent. And so I can add 2 and divide or multiply by -1. So now that I've got a more specific y-intercept and x-intercept, I can go plot those and get a little bit more accurate with my graph. So let's see, when I did my rough sketch, this point, well, I didn't label this point, did I? Oh, yeah, I did. -2, -7 was this point right here. So -2, -7 is about right here. And my y-intercept was -31/4, which is what, -7.75, so just above -8. Right, we had the horizontal asymptote at -8. And then we had our x-intercept at -5, and so now we can fill in the graph. And so this asymptote was at -8. And so that's a nice picture of the graph of that function.